Hey there! So let's talk about something that probably keeps a lot of us up at night. Data leaking from our Azure services. Like a storage account or a SQL database. Trying to secure them individually can feel like a losing battle. Well, today, we're going to break down exactly how you can build a virtual fortress around your Azure Platform as a Service resources to stop data exfiltration in its tracks.
All right, here's our game plan. First, we'll look at the whole problem of building walls in the cloud. Then, we'll introduce Azure's awesome solution, security perimeters. After that, we'll dive into the two crucial modes, transition and enforced. We'll walk through a safe plan to get you there, see how to lock down new stuff from day one, and finally explore what happens when you flip that final switch to full enforcement.
So, first things first, we really need to get our heads around the fundamental challenge here. How do you build effective security walls up in the cloud?
And that really is the million-dollar question, right? Think about it. In a traditional data center, you have a nice, clear boundary. But in the cloud, your services are all individual endpoints. So how in the world do you wrap a tight, secure perimeter around just one of them, keeping the bad guys out while letting the good traffic in?
Well, Microsoft's answer to this puzzle is a totally new way of thinking about security perimeters. You can almost picture it like having a personal private security detail assigned to each of your most critical Azure resources. It's called a Network Security Perimeter, or NSP for short. And you can think of it as a virtual, software-defined boundary that you literally draw around a service or a group of services. Now, the most important piece of this whole thing is a single, super powerful property that controls all its behavior. It's called access mode. Okay, so that access mode property, this is where things get really interesting. It has two possible settings that you absolutely have to know inside and out, transition and enforced. Let's break them down. So first up, we've got transition mode. This is your starting point, and it's designed to be completely safe. When a connection request comes in, Azure looks at your shiny new perimeter rules first. But if it doesn't find a match, it doesn't just block the traffic. It falls back and checks the resource's own old-school firewall rules. It's kind of like a safety net. And then you have enforced mode. This is the end game. When a resource is in this mode, it is completely locked down. It listens only to the network security perimeter rules. That's it. Any other firewall configs on the resource itself, they're totally ignored. The perimeter becomes the one and only source of truth for who gets in. And this right here just boils it all down perfectly. On the left, you see transition mode is basically additive. It's your new perimeter rules plus your old firewall rules. But on the right, enforce mode is totally exclusive. It is the perimeter rules and the perimeter rules only. Grasping this simple difference is absolutely key. Okay, so that's the theory. But how do you actually implement this on your real live production resources without, breaking everything and causing a major outage? Well, that's exactly what the Safe Transition Plan is for. You see, you always start in transition mode, and for very good reasons. It's designed specifically to prevent disruptions because it has that fallback to your old rules. But the real magic here is in the diagnostic logs. The logs will tell you exactly why a connection was allowed. Was it your new perimeter rule, or was it an old firewall rule? This lets you analyze everything safely and find any gaps before you lock it all down for real. And don't just take my word for it. The documentation makes it crystal clear. It says transition mode is meant to be just that, a transition. It's a temporary phase for you to learn and analyze your traffic. The goal always is to get to that fully secure state, which means getting to enforced mode as quickly and as safely as you can. And the process itself is really just a simple three-step dance. Step 1, add your existing resource to a new perimeter and put it in transition mode. Step 2, turn on diagnostic logging and just watch. Analyze the traffic to build out and refine your perimeter rules. And step 3, once you're sure all your legitimate traffic is covered, you just flip the switch to enforced mode. Done. Now, that's the plan for all your existing stuff. But what about when you're spinning up something brand new? Well, for those, we can take a secure by default approach that locks them down from the very second they're created. This is where another super handy property comes into play. It's called secured by perimeter. When you set this at the moment you create a resource, that resource is basically born locked down. It has zero public network access. The only way in is through a private link until you explicitly add it to a security perimeter. This is huge for preventing accidental public exposure. Now I know, trying to keep track of how all these different settings interact,
public access on, public access off, transition enforced, it can kind of make your head spin. But don't worry, this next table lays it all out for us nice and simple. This table is fantastic, really. Just look over at that rightmost column for enforced mode. See how it always says NSP rules only? Every time. And check out the row for secured by perimeter. Access is flat out denied until it's in a perimeter, at which point, again, it's NSP rules only. This just shows you, plain and simple, that the safest place to be is in that bottom right quadrant. So let's talk about that end goal. Let's really zero in on what happens when you finally lock the gates and move a resource into full enforced mode. Okay, so once you're in enforced mode, a few big things change. First, public access is off by default, period. It's only allowed if you have a perimeter rule that explicitly says so. Second, those old trusted services exceptions, yeah, those are gone, because perimeter rules give you way more precise control. But, and this is really important, your existing private link access is completely untouched. It just keeps on working.
So the bottom line is this. Enforced mode is all about simplifying your security by being more precise. It brings all your access rules into one single place, the perimeter. And it gives you that fine-grained, granular control to decide exactly what can and cannot talk to your most critical services.
And all of that leaves us with one last big question. When you think about your own Azure environment, and now that you know about these tools, the safe transition plan, the detailed logging, the secure by default options, the real question you have to ask yourself is your perimeter ready to be enforced?